Hi everybody, welcome to this next video. So in this one we're going to be talking about direct and inverse proportion. I'm going to talk about this in terms of what it would look like for foundation pupils first of all, and then we're also then going to look at some of the higher questions and how we can use direct and inverse proportion as a formula, and go through some of those problems as well. So let's just begin by looking at actually what direct and inverse proportion are. So if we think about direct first of all, so this is direct proportion. Direct proportion basically means as one value is going up, the other value is also going up, and it goes up at the same rate. So for example, if I said to you this value here for y was at 2, and then this value over x was at 4, for example, so let's just kind of note that. Let's just say, for example, this point here, if that was 2 and that was maybe 4, it could be 2 and 2, it doesn't matter. Then what would happen is as we go across this line, as the y value here gets to 4, so that doubles, then what happens here is this also doubles. So this would become 8. Okay, so if one side doubles, the other side doubles. So you were kind of looking at scale factors there as well. Okay, so that's your first thing with direct proportions. So as one value increases by a certain amount, the other value will increase by the same amount. Now let's look at an example in context here. So we've got this example at the bottom. So it says I use 200 grams of sugar. So I use 200 grams of sugar to make 20 biscuits. So how many grams of sugar would be used for 50 biscuits? Well, we can kind of just go 20 biscuits first of all equals 200 grams, and I want to get to 50. So there's a couple of ways you can think about this. It's like, well, how do I go from 20 to 50? Well, I could either say I times that by 2.5. Okay, so 20 times 2.5 would give you 50. So therefore you've got to times this by 2.5 as well. Or you could go, right, well, if 20 biscuits is 200 grams, then 10 biscuits would actually be 100 grams. So we're dividing that by 2. Divide that by 2. And then you've got to think to yourself, well, how do I get this to 50? Because that's actually what I'm trying to find. And to get that to 50, you then would times that by 5. So you then times this side by 5 as well. So it gives you 500 grams. So your answer would end up being 500 grams. Now that's quite a nice, easy example to look at because there's a few different ways to do it. So that is an example of direct proportion because this value here to this value here still stays the same as I get from here to here. So for example, if you look at this, to go from 20 to 200, I've actually times by 10. To go from 50 to 500, I've actually times by 10. If you look at it being 10 biscuits, to go from 10 biscuits to 100 grams, I still times by 10. So that is an example of direct proportion. So we can see it in recipe questions quite a lot as well. So let's just shift on now and look at inverse proportion, okay? So it's slightly different. So what we can say is that as one value is increasing, the other value decreases at the same rate. So let's look at this, for example. The y value here, let's say this is going down, okay? Let's say that's decreasing. So as the y value goes down, the x value is actually going up. So let's choose this point, for example, here. Let's say that on the y-axis was 10, and we'd say maybe that would be something like 1 on the x-axis. As this y value decreases, so let's now call that 5, okay? So let's say that is roughly at 5. At that point there, your x value would therefore end up being 2, okay? And it also works the other way around as well, so you can reverse this effectively, and you can say that as this x value reduces, this y value goes up. So when x is 2, that we've got there, when x is 2, y is 5, so that's higher and that's lower at 1 and that's higher. So let's now look at an example question here where we have an example of inverse proportion built into a question. So it says it takes 8 builders 40 days to build a house. So I know 8 builders is equal to 40 days, okay? I want to know how long it's going to take 10. Now, if you think about this, the number of days has to decrease, because if I've got more people here building a house, this should go down. You know, if I have 8 builders building a house and then I said 16 builders, there's twice as many people, it should only take 20 days. So follow a bit of logic here in these questions. The way I approach these questions is by thinking to myself, how many days overall should it actually take to be built? If I've got 8 people and each one of those people is working for 40 days, okay, all 8 of them are on site building that house for 40 days, well, 8 times 40 is 320 days. So for everybody's time, it is taking 320 days of combined time to build this house. But I don't want to know for 8, I want to know for 10. But this still stays the same. It will still take 320 days to build this house. It doesn't matter how many people I have building it, it will take 320 days. Now, what that means is if one person was building it on their own, it would take 320 days. So what you do is you say 320 days, and then you just divide that by 10, because I've now got 10 people, and that gives me 32 days. Okay, so you take the total number of days that it will take, in this case 320, and divide it by how many people there are. Now there is another way of looking at this. You can think to yourself, how do I go from 8 to 10? Well, to get from 8 to 10, I times by 1.25. Okay, and if you didn't know how to do that, you could do 10 divided by 8, and it gives you 1.25. But I can't times this by 1.25. That wouldn't work, because if I times that by 1.25, what I end up having is a number that would end up being higher. It'd take me 50 days. Well, that doesn't make sense. So because this is now inverse proportion, you're multiplying that left-hand side by 1.25. So here, you end up dividing that by 1.25. And when you do 40 divided by 1.25, you end up with 32 days. So remember, as one value increases, this value should decrease, okay? Because we're talking about inverse proportion here. So the left-hand side would be your increase, so that would be your x value effectively. So if we wanted to plot this on a graph, we'd say this is builders, number of builders, and then this would be your number of days. So if I had 10 builders here, it would take less days than if I had 8 builders there. Okay, so that's how you can use your inverse proportion in a contextual question like this. Okay, so let's look at an example now where it's in context a little bit, and what we can actually start to do is we can start to think about what it would look like if we were to do a graph. So let's visualize this for a second. A taxi driver charges a fee of £4. So this is your pickup fee. Okay, so it doesn't matter how far you're going, you're paying £4 and then £2 for each kilometre travelled. So this is kind of like your rate that you're paying basically. Okay, so what we're basically saying is that on the bottom we'd have kilometres, and on the y-axis we'd have charge. Okay, what I know is that I'm paying £4 no matter what. So let's say that was my £4, so that's £4 there. Doesn't matter how far I'm travelling, I'm paying that much money. From here, what you could then start to think about is how this would look on a graph. Now, if I say each one of these is a kilometre, so that'd be a 0, 1, 2, 3, 4, 5, 6, etc. And I know that for every kilometre I travel, I'm being charged £2. So if I travel 1 kilometre, it would be £2 more, because this value here would be 5, this value here would be 6, 7, 8, 9, 10. So the next value, so 2 kilometres, means I'll end up being charged £8. I then get to 3 kilometres, and then I'll end up going to £10. So what you can see here is that this ends up being a graph that looks something like this. Now, this helps us just visualise effectively what the graph would look like, and therefore I could estimate values from this. But if I then look at how much would it cost to travel 8.5 kilometres, 8.5 kilometres would be here, so that's 8.5, and you would be able to read up on your graph to see where that line hits, and you'd be able to work it out from there. Okay, now the other thing you could just do is look at this and go, well, 8.5 kilometres, and it's £2 for each kilometre, so I'm timesing that by 2. So 8.5 times by 2 is 17. So I know it cost me £17 straight away. But that would be if I was starting at 0. So if my graph went like this, and it was £2 for every kilometre and it just went up like that, then that's how much it would cost there. But because I'm now starting at 4, you then have to add your £4 on top, which ends up giving you a total of £21. So this, although this isn't direct proportion exactly, it is an example of a proportionality question. Direct proportion has to go through the origin. Direct proportion has to start at 0, and this graph doesn't. You don't need to use the graph to answer this question, but it can kind of help you just to visualize and see what's happening. So that's an example where we can look at graphs with direct proportion. Let's now look at this. Okay, so the other style of question you can get asked with direct and inverse proportion is to identify which graph represents which equation here. Now, what we need to understand is what these represent. So this is direct proportion. I'm just going to call that dP for direct proportion. This is also a direct proportion. This is also a direct proportion. And this is actually an inverse proportion. Okay. So when we're talking about what we've spoken about in this first part of this video, direct proportion, as one value goes up, the other value goes up by the same amount. The first three will be an example of direct proportion. This last one will be an example of inverse proportion. So from there, you should be able to see quite quickly that this one here looks like that inverse proportion graph we had here. So we can link that last one straight away to C. With direct proportion, okay, a perfectly direct proportion graph must go through the origin. Okay. So which one of these goes through the origin? Well, we can see the first one, the second one, and the fourth one do go through the origin. But this is a textbook. As one value goes up, the other value goes up. So it looks very similar to what we have here. So with direct proportion, you'll be able to see you have a straight line perfectly going through the origin, and it is continuous. It has the same gradient and it doesn't change. So as this value goes up, this value goes up, and it will be by the same scale factor each time. So that is your textbook example. So now what we've got is we've got two different examples of direct proportion that are slightly varied. Now this is saying that y is equal to a particular value, so we've got to find the constant first, multiplied by the x value squared. So what we end up having here is something that looks a bit like an exponential graph. Exponential graphs are ones that are things like population, so they explode very quickly and they accelerate very quickly. So an example of this kind of graph actually is this one here, is D, because that x value is being squared to make your y value. And there is a constant involved in it, but it accelerates very quickly. And this curve here, the gradient of this curve goes up very quickly, and it would continue like this and go up almost vertically. And so that leaves your last one as A. It is a direct proportion graph, although it's not going perfectly up in a straight line like that. As one value is increasing, the other value is also increasing. And that is how we end up with that third example there of A. So we can see direct and inverse proportion in graphs as well. And that's what I was saying in this example. Sometimes it can help to visualize it. You don't have to in this case, but sometimes it can help you visualize what that graph looks like to then help you with this style of question as well. So let's move on now to a couple of other example questions that you might get. This is a really common question that comes up in the GCSE Foundation and in Higher. So these values are inversely proportional to each other. So this is very similar to what we did at the start when we were looking at inverse proportion. If it's taken 120 minutes to fill in a swimming pool with 5 taps, so we say 5 taps is equal to 120 minutes. Now, because I've done an example like this already in the first part of this video, if you wanted to, you can pause the video here and have a go at trying to answer this yourself, thinking about using the scale factor. Or you could figure out how many minutes it takes altogether overall and then go from there. So if you want to pause the video and have a go at it now, and then I will go through it for you. Right, okay, so let's look at this from two different methods. First one, if I've got 5 taps and they're taking 120 minutes, each tap is running for 120 minutes. So I do 5 times by 120, which gives me a total of 600 minutes. Okay, so I know that the taps will be running for a total of 600 minutes. So it doesn't matter how many taps I've got running, 600 minutes is what it takes to fill up this swimming pool. Now I've only got 3 taps, so therefore you need to do your 600 divided by 3, and therefore that gives you a total of 200 minutes. So what that means is it will take 3 taps, 200 minutes to fill up that swimming pool. Okay, each tap will be running for 200 minutes because it doesn't matter how many taps you've got, it will still take 600 minutes. That's your total time. It will take 600 minutes to fill that swimming pool up. Now this second part of the question is really interesting. What assumption are we making here? What we're effectively saying here is that these 3 taps will run at the same pace as the 5 taps are running up here. So the flow of water is exactly the same for all of the taps. It doesn't necessarily mean it is exactly going to be like that. That is an assumption I'm making, because in reality what you could have is one of those taps could have a leak, so it maybe doesn't flow as fast. One of the taps might be turned on slightly faster than the others. The pressure might be different. So it is an assumption we are making, and this will generally happen with these questions. You'll always get asked part B that says state any assumption you're making, and the assumption here is that all taps flow at the same rate. Okay. Now, if one tap was slower or faster, it would change this time. Okay, here's an example for you to have a go at now. So it takes 4 people 14 days to fit a new kitchen in a house. How long would it take 7 people? So, and then the second part of that is stating the assumptions. Have a go at this one. So pause the video if you want to. Have a go at this one, and then I'll go through it with you. Okay, so 4 people. 14 days. So I do my 4 times 14. So how do I get, so 4 times 40, you can do 10 times 40, 10 times 4, sorry, which is 40, and then 4 times 4, which is 16, so you end up with 56 days altogether. So I know I've got 56 days of work that need to be done. 56 days of work that it will take, so it will basically take 56 days to do this kitchen. And now actually I don't have 4 people, I've got 7, so you're doing 56 divided by 7, which gives you 8 days. So it would take them 8 days to complete that work. So that's your answer. So it would take 7 people, 8 days. Your assumption here that you are making is that the people are all working at the same rate. So all people work at the same rate. Okay, again, probably not necessarily the case. There might be some people that work faster than other people's, but it is an assumption that we are making in this question. Okay, so that's your 2 examples there that we see quite commonly in GCSE papers. Moving on now to, again, Foundation Higher, an example of ratio questions, proportion questions, but they come up in recipe questions, okay? So Jenny wants to make 24 flapjacks. This is the ingredients for 16. So this, again, the reason that this is a direct proportion question is because I know for 16 flapjacks, I need 120 grams of butter. I need 140 grams of brown sugar, 250 grams of oats, and 2 tablespoons of syrup. Now, if I was doing 32 flapjacks, I would just times this by 2. So that's directly proportional, because as this doubles, this is also doubling. Okay, so that's where this is actually effectively a direct proportion question. But I'm being asked now to make 24 flapjacks. So what you need to think to yourself is, how do I go from 16 to 24? Now, this is where your scale factor can come in again. You could think about what you multiply 16 by to get to 24. Now, I know to get from 16 to 24, I actually times it by 1.5. Okay, so this means that each one of these values would need to therefore be multiplied by 1.5. And so that becomes a direct proportion question effectively. Okay, it is a recipe question, but it does link into direct proportion. So if I do 120 times by 1.5, I get 180 grams of butter. If I do 140 times 1.5, I get 210 grams of sugar. If I do 250 times 1.5, I get 375 grams of oats. And if I do 2 tablespoons of syrup times 1.5, I end up with 3 tablespoons. Okay. So the other way you can look at this is if you weren't confident multiplying by 1.5, you could think, well, how do I go from 16 to 24? I add 8. You could also make this to 8 by dividing by 2. So you could divide all this ingredients by 2, which means I'd end up with 60, I'd end up with 70, I'd end up with 125, and I'd end up with 1. And then you could just add the values together. So 120 plus 60 gives you 180, 140 plus 70 gives you 210, 250 plus 125 gives you 375, and 2 plus 1 gives you 3. So there's various ways of doing this. Depends how confident you are with multiplying with a scale factor here. You could also just divide by 2 there. Okay. So next up, we're going to look at direct and inverse proportion for higher pupils. How does a higher pupil approach a direct and inverse proportion question compared to a foundation pupil? Now, this is an example of a higher question. X is directly proportional to t. When x is equal to 6, t is equal to 4. Find x when t equals 10. There's a lot of information there, and we're going to go through it step by step as to how you actually solve these direct and inverse proportion questions. The first thing you need to be aware of is that for direct proportion, now you would have seen this sign when we're looking at the graphs. This sign basically means is proportional to. We can just replace that though. Instead of using that symbol, so this is proportional to, we can just change it to y equals kx. Okay, this is the same thing as this. So this is for direct proportion. Okay, this is a formula you need to use. And the thing that you've always got to find is this value of k. K is effectively like your constant value. So that means that to find the value of y, I multiply x by the same value each time, and that same value is k. So let's look at it in this example here. It says x is directly proportional to t. So although I don't have these letters here, I can just say x is directly proportional to t. So x equals kt. Your first step here, okay, and this will always be the same for direct and inverse proportion questions on higher, is to find the value of k. Now, how do I do that? Well, if I substitute in what I know, x is 6, so I can change this for 6. I don't know k yet, and I know t is 4. Remember that kt means k times t. So I change that t now to 4. To find then this value of k, so 6 is equal to 4k effectively, you need to isolate this k on its own. I want to get k on its own. So what I do is I take this 4 and I move it over here. And when I move it over the equal sign, it now becomes a divide by 4. So you're effectively saying 6 divided by 4 is equal to k. Well, 6 divided by 4 is 1.5. So k is equal to 1.5. Now you've found your value of k, you substitute k back in the equation. Now what I mean by that is, this is your equation up the top. So we say x is equal to, we now know what k is, 1.5 t. Because 1.5 times t, kt means k times t, 1.5 times t. So this is your step 2. You substitute this value of k that we found back into this. Okay, from here, we now need to solve this next part. And the next part down here is it's asking me to find x when t is equal to 10. So now we use this, okay? So step 3 is to solve the equation. So x, we don't know. We're trying to find x. So I just write x there. I know that t is equal to 10, so I just say 1.5 times t, which is 10. Well, I can work out 1.5 times 10, that's 15. So therefore, x is equal to 15. Okay, so that's direct proportion. The first thing you must do is find your value of k by using this. So we write the formula out, we substitute in the two values that we know, rearrange it, find k. Once you've found k, you substitute it back into your initial equation here. That gives you your value that you need to be able to find. That's your value of k. And then you substitute in for the second part to find your x value. Okay, so now let's look at inverse proportion. So here's an example of an inverse proportion question. What we're saying here is that instead of using y equals kx, we're saying y is inversely proportional to k over x. So we can also write this as y equals k over x. Okay, this is your inverse proportion. So these are the two formulas that you need to remember. So you need to remember this one up here, y equals kx, and you need to remember this one here, y equals k over x. So if we look at the values now again, we're still going to follow the same steps. We're going to find k first, but this time we've got s and t. So we're saying s is inversely proportional to t, okay? Then it tells me when t equals 0.4, s is equal to 20. So that's what I've now got. I've substituted in my information to there. Now we need to rearrange this again. This here is a divide by 0.4. So when it goes over there, it becomes a times by 0.4. So you're saying 20 times 0.4 is equal to k. So therefore k is equal to 8. Okay. So 20 times 0.4 is 8. So k is equal to 8. Then you go back up to your original equation. And we say s is equal to 8 over t. So for this question, that is your formula that you would use. S is inversely proportional to t. So to find s, you do 8 divided by t. And if we wanted to find t, we'd rearrange this, but we don't need to in this case. So it says calculate the value of s when t is 0.5. Okay, so let's substitute in what we know now. We know t. So s is equal to 8 divided by 0.5. So therefore, to find s, I just do 8 divided by 0.5. Now, you need to be very careful here because a lot of people would put an answer down as 4. 8 divided by 0.5 is not 4. Okay, 8 divided by 2 is 4. So you need to be very careful. 8 divided by 0.5 is actually 16. Okay, because you're effectively timesing 8 by 2. So s would therefore be equal to 16 in this example here. Okay, so what we're now going to just quickly look at as the last section here is direct inverse proportion when it's worded ever so slightly differently. So the concept is still the same, it's just that we're going to need to be careful with the way that it's worded. So if we look at this one here, it says y is inversely proportional. So the first thing I should be thinking of is y is inversely proportional. So I know that that's going to be the formula I'm using. But now it says the square of x. So we're going to actually write this as y is inversely proportional to the square of x. So that's x squared. So that wording is really important. And then you change your formula to match it. So it's really important you understand that difference there. In the previous ones, there was no square or square root. In this example, we have got a squared in it. So now I just use that formula I've just created. And I follow the same process. So y is 1, so I go 1 is equal to, I don't know what k is yet, and x is 10, but remember I've got to square that. So it becomes 1 is equal to k over 100, because 10 squared is 100. Take that over that side, and because it's a divide by 100, when I then move it over here, it becomes a times by 100. So we're saying k is equal to 100, so therefore my formula becomes y is equal to, k is 100 now, divided by x squared. So this is your formula that you've created, and then from here I then substitute in the values that I've got here. So find the value of y when x is equal to 5. So you're saying y is equal to 100 divided by x being 5. 5 squared is 25, so you're doing 100 divided by 25. So therefore y is equal to 4. Okay, so when y is 5, when x is 5, y would be 4. Okay, so that's your example there. If you want to pause the video, you can have a go at this next one now and see if you can get your head around what you need to do. So as I say, pause the video if you want to, and then I'll go through it. So L is directly proportional to the square root of v. So L is directly proportional to the square root of v. It means that my formula would look like that. So that's what you should be starting with now. Because we know that it's direct proportion, it will be L is equal to kv, but because it's a square root, that v turns to a root sign above it. Now we go back to what we know. So L is 36, so 36 goes there. We don't know what k is, and we know that v is 16. And remember that here, this k root 16 means whatever that is times by the square root of 16. So we're saying 36 is equal to k times by square root of 16 is 4. So therefore we have 36 is equal to k times 4. Take this 4 over, and we divide it by 4. So you have 36 divided by 4 is k, so k is equal to 9. Go back to your initial equation up here again, and we say L is equal to 9 root v. So substituting what we know, we need to find this now, so it's a bit different. We know that L is 27 is equal to 9, and this is times by the square root of v. So because I'm trying to find this, I've got to take the 9 over here and I divide, because that's 9 times. When I move it over, it becomes a divide by 9. So we're doing 27 divided by 9, which is 3. Now what we're saying is 3 is equal to the square root of v. So to get rid of this square root sign, because I want v on its own, the opposite of square root is squared, so I need to square 3. So 3 squared will be equal to v. So if you're not sure what I've done there, I need to get rid of this square root sign. And in order to get rid of the square root, you square it. That is the opposite of square root. So take that over, and 3 squared is 9. So v is equal to 9. So v would be 9 when L is 27, and we can substitute that back in here just to double check. So if I said L was 27 is equal to 9, and then the square root of v, we're saying v is 9. So that's 9 times the square root of 9, or the square root of 9 is 3, and that's 9 times 3. So 9 times 3 is 27. So that does work. Okay, a little bit more of a complex example there in those two, but that is our direct and inverse proportion. They are the basics from all the way through, from foundation all the way through to higher. Hope you found this video useful. I appreciate it was a bit of a longer one, but it's worth going back and skipping through certain parts that you need to recap on. Hope you found it useful, and I'll see you on the next video.